Okay, in this video, we're going to be looking at percents. And what we'll be doing in this video is finding percents. We're going to be looking at some applications that involve percents. We're going to be dealing with some mental mathematics that involve percents, estimations with percents, and we're going to be computing interest. In this case here, percents are special kinds of fractions, namely fractions with a denominator of 100. Okay, so the word percent comes from the Latin phrase percentum, which means per hundred. And of course, the definition of a percent would be n percent, which is going to be that number n over 100. So anytime you want to convert a percent to a fraction, just put that number over 100. And sometimes you may have to do a little bit of reducing, writing the fraction in its simplest form. But let's look at some of these type of problems here where you want to write each of these decimals and fractions as a percent. 0.03 as a percent. When you're converting a decimal to a percent, you always move the decimal point 2 places to the right. So here we move this decimal point 2 places to the right, so that means it'll end up behind the 3. The decimal point will end up behind the 3. So you'll have 3%. So 0.03 as a percent will be 3%. Then 0.03, where the bar is above the 3, that shows that this 3 repeats on and on without end. But still, you're going to move the decimal point 2 places to the right, so I wrote it like this in its expanded form. So if you move the decimal point 2 places to the right, you'll get 33.3. But since the 3 repeats, so that means we write it like this, 33.3 with the bar above this 3 right here, and then tack on the percent sign. Okay, so anytime you're converting a decimal to a percent, you move the decimal point 2 places to the right and add the percent sign. Part C, 1.2 as a percent. Here we move this decimal point in 1.2 2 places to the right. In this case, we have to add a 0 behind it. So it'll be 120 with the percent sign. 120% is the percent for the number 1.2. And 0.00042 as a percent. Again, you move the decimal point 2 places to the right. That means that this decimal point will be behind the second 0. So it'll be 0.042%. And for E, the number 1. Now, there is no decimal point, but it is understood to be behind the very last digit in that whole number. So here we move this decimal point 2 places to the right. We need 2 zeros there, so it will be 100%. Now for 3/5 as a percent. Now you can convert 3/5 by doing 3 divided by 5 using long division, and you'll end up with 0.6. So 3/5 as a decimal will be 0.6. But you want to convert it to a percent, so we need to move this decimal point 2 places to the right and put a 0 behind it. So it'll be 60% for 3/5. Part G, 2/3. Now you can do 2 divided by 3, which will be 0.666. Of course, the 6 repeats, so that means we put a bar over this 6. And then we're going to move the decimal point 2 places to the right to convert it to a percent, so it'll be 66.6 with the bar on top, and then add your percent key symbol to it. Now for 2 1/7, this one's going to be a little bit difficult to try to convert to a percent. But let's do this. If I do 2 1/7 times 100, I'm going to convert 2 1/7 to an improper fraction, which will be 15/7. That's 2 7 times 2, that's 14, plus the 1, that gave me the 15 over 7, times 100 over 1. And then multiply 15 times 100, that's 1500, divided by 7 times 1, which is 7. So if I divide 7 into 1500, that's going to give me 214. And I think I have like 2 left over, 2 sevenths. And of course you can use the calculator for this. So if you do 1500 divided by 7, the 214, and then if you try to convert it to a fraction, you get the 2 sevenths, and then add the percent. Okay, because moving the decimal point 2 places to the right is the same as multiplying by 100. Okay. Now let's work backwards, converting each of the following percents as a decimal. 5% as a decimal. When we convert a percent to a decimal, we drop the percent sign and move the decimal point 2 places to the left. So in this case here, 5%, we drop the percent sign, move this decimal point 2 places to the left. So now we got 0.05. Here, the decimal point is understood to be behind the last digit. So we move it over 2 places to the left. Or you can divide by 100 if you want to. And you'll get that 0.05 as your answer. 6.3% as a decimal. Again, we drop the percent sign. Oops. 6.3%, I'm sorry. Drop the percent sign. Move this decimal point 2 places to the left. So you have to put a 0 there, so the decimal point will be in front of the 0, so it'll be 0.063. Or do 6.3, divide that by 100, and you'll see you'll get the 0.063. Part C, 100%. Here we drop the percent sign and move the decimal point 2 places to the left, so it'll be behind the 1. So 100% as a decimal will be 1. Or 100 divided by 100 will give you the 1, if you want to do it that way. Part D, 250%. You can divide 250 by 100, you'll get the 2.5. Or drop the percent sign and move the decimal point 2 places to the left. Now part E, you got 2/3%. If I convert 2/3% as 2/3 as a decimal will be 0.6, repeating. And that's as a percent. But I want to convert that to a decimal, so here, move it over 2 places to the left. It'll be 0.006 with a bar on top of the 6. Okay, disregard this answer right here. This is the correct one. Okay, now 33 1/3% as a decimal. Okay, in this case here, I'm going to take 33 1/3 and divide by 100. I'm going to convert 33 1/3 as 100 over 3. I'm converting that to an improper fraction. Then I'm going to multiply by the reciprocal of 100, which is 1 over 100. And this is going to be quite easy because these 100s will divide out. I'm left with just simply 1/3. But 1/3, if I convert that to a decimal, will be 0.3 with a bar on top. And this one on here is incorrect. So it'll be 0.3 with a bar on top as your decimal. Let's look at some applications that involve percent. Applications involving percent usually fall into one of the following forms. Number one, you're either finding the percent of a number, or you could be finding what percent one number is of another, or you can find a number when a percent of that number is known. In this example, we have a house that sells for $92,000, requires a 20% down payment. What is the amount of the down payment? So in this problem, we want to find 20% of 92,000. So here, 20% of 92,000, the word of means we're going to multiply. Now, if you change 20% to a decimal, you're going to get 0.20, and you're going to multiply that by 92,000 to get $18,400. So the down payment on that house would be $18,400. Okay? And by the way, that particular example is is the example of finding the percent of a number. Okay? This next example, it deals with finding what percent one number is of another. If Alberto has 45 correct answers on an 80-question test, what percent of his answers are correct? So now we're finding what percent of 80 is 45. Now here they set this up as a proportion. The number he got right is 45 out of 80. So that's 45 over 80, and it's equal to, now we want to find out what percent n over 100. So in this case here, to find out what n is, we multiply both sides by 100, so you're going to get 45 over 80 times 100, which will give you n, and n, of course, will be 56.25. So 56.25% of Alberto's answers are correct. That's an example of finding what percent one number is of another. Okay, this one is finding a number when a percent of that number is already given. In this case, 42% of the parents of the school children in the Paxton School District are employed at DePaloma University. If the number of parents employed by the university is 168, how many parents are in the school district? So here we want to find the number such that 42% of that number is 168. And we're going to let n be the number of parents in that school district. That means that 42% of n is 168. 42% as a decimal will be 0.42 times n. The word of means multiplication, so it'd be 0.42 times n is equal to 168. Now take 168 and divide by 0.42, you'll get 400. So that means that there are 400 parents in the school district. Okay, here's another example. Kelly bought a bicycle and a year later sold it for 20% less than what she paid for. If she sold the bike for $144, what did she pay for it? Now here we're looking for the original price, which we'll call P, that Kelly paid for the bike. We know that she sold the bike for $144, and this included a 20% loss. So the expression would be this: $144 will be equal to the original price minus Kelly's loss. And Kelly's loss is 20% of the original price, so it will look like this. $144 is equal to P minus 20% of P, or P minus 0.20P. And 1P minus 0.20P is going to be 0.80P. Okay? So if her loss was 20%, that means that she only sold the bike at 80% of whatever the original price is. So that's where the 0.80P comes from. Now, to find out what P is, you're going to take 144 and divide that by 0.80 to get $180. So that means that Kelly paid $180 for the bike. Okay, another example would be Westerners clothing store advertised a suit for 10% off for a savings of $15. Later, the manager marked the suit at 30% off the original price. What is the amount of the current discount? Okay, so here, a 10% discount amounts to a $15 savings. We could find the amount of the current discount if we knew what the original price was, which we're going to call P. So here the original price was $150. Okay, now how did they get the $150? You take $15, divide that by 0.10. 10% as a decimal will be 0.10. Because a 10% discount means that there is a $15 savings. So 15 divided by 0.10 will give us $150, which was the original price. Now to find the current discount, we're going to calculate 30% of $150, which is 0.30 times 150, which would give you $45. So the current discount would be $45. Okay, next we'll look at some mental math that has percents in it. So here we're going to use fraction equivalents. Okay, now 25% as an equivalent fraction will be 1/4. 50% as an equivalent fraction will be 1/2. 75% as an equivalent fraction will be 3/4. 33 1/3% as an equivalent fraction will be 1/3. 66 2/3% would be 2/3 as an equivalent fraction. Then you got 10% as an equivalent fraction would be 1/10, and 1% would be 1/100 as an equivalent fraction. Sometimes you'll be able to use these as a way of helping you calculate, work out problems that involve percents. Let's see. In using a known percent, frequently we may not know a percent of something, but we know a close percent of it. For example, to find 55% of 62, we can do the following. 50% of 62 would be this. Well, 50% is a half, so that's 1/2 of 62, which is 31. And 5% of 62 will simply be 1/2 of 10% of 62. Now, 10% will be 0.10 times 62, which will be 6.2. Half of 6.2 will be 3.1. Now add the 3.1 to the 31, you're going to get 34.1. So using mental mathematics, we can find 55% of 62 in this particular situation. Estimations with percents can be used to determine whether the answers are reasonable. Like in this situation, Laura wants to buy a blouse originally priced at $26.50, but now on sale at 40% off. She has $17 in her wallet and wonders if she has enough cash. How can she mentally find out? And we're going to ignore the sales tax. So in this case, it's easier to find 40% of 25 as opposed to finding 40% of $26.50. And we can do that mentally. If we do 40% of 25, that's the same as saying 4 times 10% of 25. So 4 times 10% of 25, which is the same as 0.10 times 25, or 2.5. Then 2.5 times the 4 would be 10. So Laura estimates that the blouse will cost $26.50 minus $10, which is $16.50. Now, since the actual discount is greater than $10, Laura will have to pay less than $16.50 for the blouse. So she does have enough cash. Okay. Which of the following statements could be true and which are false? In Part A, Leonardo got a 10% raise at the end of his first year on the job and a 10% raise after another year. His total raise was 20% of the original salary. That statement would be false. And you can come up with counterexamples that would say that this will be false here. Because let's say $10,000 a year, he got 10% of that. That's $1,000. So that means he has an $11,000 salary. And then he got another 10%, which I'm going to say in this case $1,100. Add that, that's going to be $12,100. So his total raise would not be 20% of his original salary, because his original salary would be $10,000 times 20% would only be $2,000. That means that his salary would be $12,000, which is in this case is going to be false. Part B, Jung and Dina paid 45% of their first department store bill of $620 and 48% of the second department store bill of $380. They paid 45% plus 48%, or 93% of the total bill of $1,000. Again, that statement would be false, because 93% of the total bill of $1,000 would be $930. And you can do $620 or 45% of 620. That would give you $279. And then 48% 380 would give you $182.40. Add that to the 279 and you'll get $461.40, which is not $930. That's less than half. So that particular statement would be false. Part C. Bill spent $25 of his 25% of his salary on food and 40% on housing. Bill spent 25% plus 40%, which is equal to 65% of his salary on food and housing. That would be true. Okay, because if he made $20,000, let's say, 25% of his salary is on food. That would be $5,000. So for food, he'll be paying $5,000. And then for housing, which is 40% of that, that would be $8,000. And that total would be $13,000. And then if you take 65% of $20,000, you would also get $13,000. So that would be true. Part D, in border towns, 65% of the adult population works in town, 25% works across the border, and 15% is unemployed. That would be false, because think of this, 65% and 25% is 90%. And then 15%, add that, you're going to get 105%, which doesn't make sense, because these totals can't add up to, cannot exceed 100%. So that would be a false statement. And then in Clean City, the fine for various polluting activities is a certain percentage of one's monthly income. The fine for smoking in public places is 40%. For driving a polluting car is 50%. And for littering is 30%. Mr. Schmutz committed all three polluting crimes in one day and paid a fine of 120% of his monthly income. That would be true because at 40, 50, and 30, you'll get 120% because he committed all three polluting crimes and had to pay that percentage of his monthly income. Now let's talk about computing interest. Suppose you borrow $6,000 from a bank at simple interest at a rate of 5% to be paid off 2 years from now. Now the $6,000 represents the principal or the amount of the loan. The 5% represents the interest rate. The period of the loan is the amount of time you owe the money. In this case, is 2 years. Okay. Simple interest means that the interest will only be computed on the principal for the stated time of the loan. And the formula for simple interest is this: I is equal to P times R times T. I represents the simple interest, the P is the principal, the R is the interest rate, and the T is going to represent the number of years, or the time. And the time is always going to be in years when we're dealing with computing interest. So the formula for the total amount, which is A, to pay off a loan is this: A is equal to P plus the I. P is your principal, I is going to be the interest. Or, since I is equal to P times R times T, A is going to be equal to P plus P times R times T, or P times the quantity 1 plus RT. Look at this example. Vera opened a savings account that pays simple interest at a rate of 5.25% per year. If she deposits $2,000 and makes no other deposits, find the interest and the final amount for 90 days. So we're going to use the simple interest formula. I is equal to P times R times T. The principal is $2,000. The interest rate is 5.25%. The time has to be in years. We're given 90 days. So it has to be 90 over 365 days because there are 365 days in a year. Now, if we simplify this, we bring down the 2,000. We want to convert 5.25% to a decimal, which will be 0.0525. Here, 5.25 or 5.25 will be 5.25 as a decimal. And then we drop the percent sign, move the decimal point 2 places to the left, so it'll be 0.0525 times 90 over 365. And that's going to give us an approximate value of $25.89 when we multiply all this out. So that's going to be the interest. The final amount would be this: the interest plus the principal, $2,000 plus the $25.89, which will be $2,025.89. So to answer that question, the interest is approximately $25.89, and the final amount will be approximately $2,025.89. Okay, find the annual interest rate if a principal of $10,000 increased to $10,900 at the end of 1 year. So R is going to be the annual interest rate. So we know that R percent of $10,000 is going to be that increase. The increase is going to be the $10,900 minus $10,000, which is $900. That's the amount of the increase. You subtract your principal from the ending amount. That gives you the amount of increase, which is $900. So what percent of 10,000 would give us 900? Well, that's R percent, or R over 100 times 10,000 would give us 900, which equates to 9%. Okay, so the annual interest rate is 9%. Next, we'll look at compound interest. When earned interest is added to the principal and then interest is earned on the new amount, that is, it is earned on the previous interest as well as the principal, this is what we call compound interest. I usually call it interest on top of interest, which will be compound interest. Compounding is usually done once a year, semi-annually, or twice a year. And by the way, once a year will be annually, quarterly, or 4 times a year, monthly, 12 times a year, or daily, 365 days a year. However, even when the interest is compounded, it is given an annual rate. So in this case, the interest rate per period is the annual interest rate divided by the number of periods in a year. So if you invest $100 at 8% annual interest compounded quarterly, how much will you have in the account after 1 year? So now it's compounded quarterly, so the quarterly interest rate will be 1/4 of 8%, or 2%. If at the beginning of any of the 4 periods there are X dollars in the account, at the end of that period there will be X plus 2% of X dollars, which is equal to X plus 0.02 times X, or X times the quantity 1 plus 0.02, or 1.02X dollars. So here we want to find the amount at the end of any period. We need to only multiply the amount at the beginning of the period by 1.02. Okay. And this is pretty much the long drawn out table of how this is done. And in this case, the amount of at the end of 1 year is 100 times 1.02 raised to the 4th, or approximately $108.24. And this is the formula for finding the compound interest. Okay, so the formula for computing the amount at the end of the nth compound interest period will be A is equal to P times the quantity 1 plus R raised to the n. And A is the amount, P is the principal, R is the interest rate, and N is the number of periods. Let's look at this example. Suppose you deposit $1,000 in a savings account that pays 6% annual interest compounded quarterly. What is this balance at the end of 1 year? Okay, so in this case here, it's compounded quarterly, so we're going to do 1/4 of 6, or 0.06 divided by 4, as mentioned in this formula. And it's raised to the 4th power. That exponent of 4 tells me that n, that's the number of periods, or compounding periods. And your P is your principal. So here, this is 1,000 times 1 plus R, which is going to be 0.06 divided by 4, raised to the 4th. If you do this in the calculator, you'll get 1,061.36. So at the end of 1 year, the balance is about $1,061.36. All right, the next question is, what is the effective annual yield on this investment? That is, what is the simple interest rate that would, after 1 year, pay the same amount as the given compounded interest rate? So now we need to look at the interest here. So if we subtract $1,000 from the $1,061.36, you'll get $61.36 as your interest. Now, the effective annual yield is going to be using a simple interest formula. Okay, so here you take $61.36, and then that's going to be equal to your P, which is 1,000, times R times T, which is 1. So now you have $61.36 is equal to 1,000 times R, divide by 1,000, you're going to get 0.06136 or 6.136% as a percent. So here the effective annual yield will be 6.136%. And to save for their child's college education, a couple deposits $3,000 into an account that pays 7% annual interest compounded daily. Find the amount in this account after 8 years. Okay, so in this case here, we use our compound interest formula here. P is going to be $3,000 plus the quantity 1 plus the R will be the annual interest rate divided by the number of compoundings. It's compounded daily, so it'll be 0.7 divided by 365. And that quantity is going to be raised to the 8 times 365. 8 years times 365 compoundings in a year. Now, if you simplify this in the calculator, you'll get $5,251.74. So after the first year, the balance will be $5,251.74. Okay, so that will conclude this particular section on percents.